All right, hey everyone, it's Victor here. So another tutorial we're going to work on today. A lot of people have asked for this. It's about heat maps. So heat maps are a pretty common thing we do with mapping. Basically a different way to show a lot of different points on the map. And I'm sure you've all seen heat maps, so we're just going to get right into it. I'm going to kind of make this reasonably comprehensive. I'm not going to go into extreme detail in all the examples, but enough so that you have a few different ways of tackling heat maps in a few different libraries. So we're going to do this in Maplibre / Mapbox. We're going to use Maplibre, but everything there applies to Mapbox as well. We're also going to use this with Leaflet, and we're going to use it with Google Maps. So I'll try to keep this organized. So we're going to do three types of heat maps. One will be proximity. So the idea there is that we're just showing the heat map to show how close each point is to one another, but they're not like weighted by any particular value. The next one will be weighted, which is basically like, it's not just each individual point, but each individual point has some value. So as an example, just proximity might be like you're trying to show how many houses are in a certain area by heat map. And a weighted one would be you're trying to show the strength of earthquakes in a certain area. So it's not just that there are earthquakes, you want to show how strong they were. Whereas the other example is you're just trying to show how many houses. So that's like proximity and weighted. And then we're also, just a little bonus, we're going to do it by cells. So we're going to like generate grid on the map and then populate the grid and color each square on the grid according to how many points fall inside that grid. Hopefully that gives you some ideas on some different types of heat maps. So we're going to roll through each of those in each library. I'm going to be using the same data set across all of them just because it's kind of easy, and that data set originally, it's coming from some Maplibre documentation, so it's going to be an earthquake data set, which is a really great thing to do a heat map of. And we're going to be using a few different libraries along the way, like turf, some color interpolation, and all those three map libraries. So let's start with Maplibre and let's get into it. So with Maplibre, we have this nice documentation here of creating a heat map layer. This is our basis. So we're basically going to copy this in, and our first one that we're going to go over is the weighted example, and that's because that's exactly what this example actually is. So if we go into our code here, we can see we create our Maplibre map, then we load it, we grab, just like in the example, we grab this data set and add it as a source. If we want to look at this actual GeoJSON, it doesn't hurt. I've got it saved here. And we can see there's each a point and there's some data on it. And the magnitude is the important one that we're going to use. Of course, we could also have a heat map over time where we filter things by time and then show the heat map like with some kind of slider. That's not in this video, but you get the idea. And we have coordinates. And this coordinates, they actually have 3 because they have an elevation as well, but that's not important for what we're doing right now. So if we go to our weighted example, the next thing we do is we add a layer. So we're going to add a heat map layer, and then we're also going to add points. And that's because on this particular one from Maplibre, it's pretty cool actually. As you zoom in at a certain point, they turn into circles, which are also scaled according to the magnitude. It's pretty awesome, honestly. It's a great way to do a heat map where you also get a lot more detail as you zoom in. We'll see the other examples don't really quite have that awesome of a zoom in functionality. So we actually have 2 separate layers that we're adding here, so it can be a little bit confusing to understand what's going on. So at the start, we're going to add a layer. It's going to be of type Heatmap. Now type Heatmap is a layer specification in Maplibre, so it's got a few options. So its options here are heatmap color, intensity, opacity, radius, and weight. So we have a few different properties here. Let's see them in action is the easiest way to explain them. So weight is going to be based on some property that we're determining. So in this case, we're going to be magnitude. After weight, we have intensity, and this isn't really terribly important. It basically like amps up the whole heat map so that if your values weren't going into enough of the scale that you wanted, like if nothing's coming out red, you can just like multiply everything so that it's more intense. It's not, I would recommend like trying your map without it first. We're going to manipulate the value, but to see more what it is. Then we have a color scale here, just a set of RGB values, which we can change out if we wanted a different color scale. And the radius, we'll play with that. And opacity is fairly straightforward. It just sets the general opacity of the heat map layer overall. So when we load in kind of with what I have there, we're going to have our heat map weighted, and this is what it is. So this is a weighted heat map by magnitude. Now, just contrasting that with what we're going to look at after, we have a proximity one, which doesn't weight it. You can see they're fairly different because this one, the proximity, is just showing each point equally, whereas this one is prioritizing certain points. So as we go in and we're going to change, let's say we change the heat map weight. What this is saying is if the magnitude is 0, then the weight is 0. If the magnitude is 6, then the weight is 1. Now the heat map weight goes between 0 and 1. So whatever your maximum magnitude would be, you probably want to make that around 1. So if we change this to instance, say, oh, if it's a magnitude of 3, then set it to 1, we're going to get a lot more red on this map. So as we load it, we see there is, again, a lot more red, and that's because we've changed the value that we're using for our weight. And if we set this to, let's say, 20 as our max, we're going to get a lot less red, if almost none, right? Just a few up here where they overlap enough that the weight together is more than 20. But you can see that disappears very quickly as we zoom in. Set that back to 6 because that's kind of a nice value. And again, we could just look through our earthquake data and sort of see, okay, 6 is sort of the maximum. Our intensity is not too important here. It's set based on zoom level. If I set it to 20, just so we see what it's about, I'd recommend you just play with this. You can see it's a little bit more intense, and yeah, it's a bit of a weird one, this intensity one. I would just play around with it to kind of, it's generally just scaling your heat map to look a certain way. Color, fairly straightforward here. It's just using this internal property called density, which is just Mapbox or Maplibre is figuring out how many points are together, and then based on how much they're together plus the weighting, it assigns one of these colors to it, and you can just set your own colors. Radius, this will basically determine how much there's going to be overlap between your different points. So here we say at zoom 0, it makes the radius of each point 2, and at zoom 9 it makes them each 20. So let's say we say at zoom 9 it makes them each 3. We're going to have a lot more granular of a heat map coming in. You can see how much it jumps around as well, but it's a lot more granular because each radius is much smaller as we zoom in, versus when we have 20, we have each point being quite large in comparison. Now for this data set, I might not particularly like that because this is a little bit too broad. So if I make it, say, 15, you might like that a little better. It gives the contrast a little bit more between the different points, but you get the idea. You can set this as needed. So that's kind of going over the general. We don't really need to go over what the circle does. That's just breaking it down into a different layer and kind of getting off base. But that's how the different properties work in the Maplibre map. It's probably the most complicated of all the ones we're going to look at with all these properties, but really you should just play around with them. Once you have a data set of all these points, you'll be able to load it in and then set these in a different way. The only difference for our proximity map, which is here, like I showed before, basically the same map, but you can see tons more red. In this case, it's not really the best way to show this type of data, but just as an example, what I'm doing here instead is I have just removed the weighted property. So instead of having this heat map weight, I just completely deleted it. And so it's not using weight anymore. It's just taking each point as its own individual thing. And the rest of it remains the same. The radius here, the color. I also got rid of the intensity because the intensity works with the weight. So if I don't have weight, I don't need the intensity. So that is fairly straightforward. You just remove the property that you were using to determine the weight. Now, the last one is the cell example, which is fairly different than the rest, in which we create this cell of polygons and then determine how many points are in each polygon and then color it using the same scale that we were using before. So to do this, what we're going to have to use is turf, actually. We're going to hop into turf.js, and we have this awesome method called hexgrid where we can pass it a bounding box and it'll return a set of hexes like this. They get a little distorted depending on latitude, longitude. They're not always like perfectly even looking like this. We can see here these ones are kind of stretched vertically, and these ones are more like compressed because of the way latitude and longitude work on a map. But the idea is that turf is creating this for us. So just to quickly walk through the code, we fetch the earthquake data because we're going to need it directly. We can't just add it as a layer as we do with the other heat map examples. We need to actually loop over it and do some spatial analysis. So we get the bounds of our map, and then we pass that into our hex grid function from turf. It's going to return like a feature collection, so a new GeoJSON. That's a whole bunch of these individual polygon grids. Then we loop over each one of them, and we do this turf points within polygon function that's going to return all the particular points from our earthquake GeoJSON that are inside that polygon that we're checking. And then based on how many points come back, I add earthquake total number to the hex grid feature, and also add the intensity just by adding all the intensities up. So that way I kind of have like, okay, this is how many earthquakes happened in this particular cell, and this is the intensity if I add them all together. I don't think that's like the most scientific way to do it, but that's how I'm doing it here for this example. And then I need to know, so I can scale appropriately, the cell that has the most earthquakes in it, how many that is, because that will be like my upper layer. Obviously, there'll be some cells that have 0, and then one cell will have, I don't know, like 50 or 60 earthquakes. And so every other cell is going to fall in between, and that helps determine what color I should pick for each cell. If I don't have that upper limit, I don't know where the most red cell should be. So that's why I keep the max. I save the max every time. Same with the intensity. I save the max intensity. Then we go down here, we add our hex grid using a fill type layer, and we just tell it for each color, it's going to be based on the earthquake number. And I have minimum, which is 0, and then you can see here I take my 20% of my maximum, 40% of my maximum, and so on. And then my maximum is the last color. And then using all that, it will shade these cells appropriately. So you can see it pretty much matches with the general intensity that we get. We get some intensity here and intensity down here, and we get the same going on in this cell map. Now, this isn't weighted or anything, so you could do things like multiplying the values together. And anyway, you get the idea generally about this cell heat map. You have to generate the cells, you have to figure out how many points are in each of them, and then color them appropriately. So that's the general idea of our proximity heat map, our weighted heat map, and our cell heat map. So now if we just take that and we're going to go into these other libraries, into Leaflet and Google Maps, and kind of look at the same thing and how we would implement them there. So now going into the Leaflet one, here is our example of our Leaflet weighted heat map, and our Leaflet proximity heat map, and our Leaflet Cell heat map. And we can see they're pretty much very similar to the ones we get from Maplibre. That's our weighted, that's our proximity, and that's our cell. So we get some very similar results, which is good because that means that we're not completely crazy. And with Leaflet, there's a couple ways you can do heat maps. There is a Leaflet like Heatmap.js library that I have used before, but this time I was looking around and I found something a little bit more modern, which is just this Heatmap.js library that's out there, where it's used as an example here for Leaflet specifically. So in this case, I'm using that in my example. And of course, if you need to go look at these examples yourself, they're all up in the repository where I save all this stuff in the Mapster Learn that is linked in the description. So if we go to our weighted one, we start with that again. You can see here we fetch our earthquake data. And then again, we find the maximum magnitude because we need to find that upper level of a scale, what's going to be the maximum. And then we follow along with the documentation and create the data object the way that this example gives us here. So we have to give it a max, and then we give the data, we give each data latitude and longitude, and whatever property we're going to be using as our intensity value. So in this case, we are having our intensity value be the magnitude, and we're recording the maximum magnitude, and then we're looping over each feature and saving the latitude, longitude, and magnitude. Then there's this config object There's a bunch of options here that are worth playing with. Again, there's a radius, which will expand how much these little heat map points are going to interact and overlap. There's scaling radius. We're going to turn that off and on. And this use local extrema is pretty interesting. Let's just see what it does because it's a little hard to explain. So let's go into our weighted version, and we're going to set our radius instead of 0.5. We're going to set it to 5 just to be extreme here and see what changes. Whoa, heat map totally changes, right? So we're going to set it back to 0.5, and there we go. And if I set the scale radius to false and then reload, you'll see that it's actually super tiny now because it doesn't scale it to be at my particular zoom level. So I would then have to set the radius to be, let's say 20, and it might actually start showing up. But it scales very quickly as I move down. So again, just different options going on there. I'd recommend just keeping the settings at scale radius true and use local extrema false. Feel free to play around with them, but it does like screw with your heat map pretty majorly. But you know, play around if you need that. But you can see here, otherwise I just set the lat field, the lon field, and tell it which value field to use, which is the same as this one I've set up above. And then I just add the layer, and this is all in that documentation. Now, if I want to do the proximity heat map in the same way, all I have to do is provide it with a different thing than magnitude, which in this case is a count. So basically what I'm doing is for each feature, I'm saying, oh, you have a value of 1. And I'm saying that the maximum of all the values that will come through is 1, because each point is going to be worth 1, and no point is ever going to be worth more than 1. So what this does is it ends up having each point having a value of 1 in the overall heat map, which is the same as counting them just by proximity, because each one is not a weighted point. So there we go with our proximity one. And our Leaflet Cell has the same, it's almost identical the way that it works with the Maplibre example. It's just a difference in how we actually add the hex grid at the end. We don't have to add it as a source and a layer like we do with Maplibre or Mapbox. Instead, we use this GeoJSON method that comes along with Leaflet and color each individual grid. One thing I did do different is I used this color interpolate library, which you can find saved as a JavaScript in the example repo. And basically color, I give it all the same colors that I gave my Maplibre example. And once I give it the particular earthquake number for a particular cell and divide it by the maximum that I've saved, which is the same as in our Maplibre example, it will give me the appropriate color along that scale. That's a really handy little library because otherwise it's really tough to know like the exact color that any particular cell should be. So we really need something like this to interpolate. So that's what I'd recommend using if you're going to do this kind of cell heat map. So okay, then we come to Google and we have the heat maps basically built in as a type of layer that they have. I'm not a big fan of the Google documentation. I do find it kind of confusing. They have some stuff about the heat map layer and then you can add it, and then they have an example with weighted points, and we have to follow along with their type of formatting. So you can see there's a location, and then we give each one a weight according to whatever value we're internally using, and then add it as a heat map layer. So in our actual code, I have to follow this specification. So I fetch the data and then loop over each point and set a location for it, and I'm using the magnitude as the weight, so I set the weight, and then I just put that as a heat map layer. And they have some different options for this. They go over them here: dissipating, gradient, max intensity, radius, and opacity again. Again, just play with these. They're kind of hard to understand, some of them. So if you play with them, you'll get the idea pretty quick. You can see that the Google Map one is okay. It's not as smooth as Maplibre, but it's smoother than Leaflet. Now, if we just go into the normal heat map, that is, you just follow the basic example here of the heat map layer. So in our proximity one, we don't need to do that weighted thing. We just return each point as an individual point and add our heat map layer. And finally, for our cell, The Cell one is, again, very similar to the others. We have our little interpolate library for the colors like we did with Leaflet. We loop over, we get the bounds, we do the hex grid stuff, we find the maximum intensity that we're going to use, or maximum points we're going to use. We do this whole interpolation thing, add a GeoJSON and color each GeoJSON appropriately based on how many points each individual polygon has in it. And we get something very similar to the Leaflet one, which is also very similar to the Maplibre one. So in all of these heat maps, they're obviously quite complicated. There's a lot to learn and a lot to go over in all of these. I generally do prefer the Maplibre one. It's the smoothest. It's really nice to use. It changes as you zoom in. But I also do like the Leaflet one. I think the visualization is quite nice. And of course, being open source, it's quite good. And it loads quickly. They can all handle a lot of points. You're not really limited by, having 1,000 or 10,000 points here. So they're all going to work pretty well, kind of up to your expertise. So in any case, I hope this video was useful for those of you looking to do heat maps. Let me know if anything was confusing and rewatch it. Take a look again, and we'll see you next time.